Okay, Assalamualaikum. For this part, I will explain about direct titration. Okay, so there are two types of titration. First is direct titration. Second is back titration. Okay, so what is the definition of direct titration? It is a direct addition of standard titrant to the analyte in the presence of acid-base indicator till the reaction is complete and reach the equivalence point. So for direct titration, it's like a normal titration where one-step reaction involved. Okay? So there are one balanced chemical equation. For example, quantification of acetic acid in vinegar. Okay, so acetic acid react with sodium hydroxide to form sodium acetate plus water. So when the equation is balanced, there are 1 mole of acetic acid react with 1 mole of sodium hydroxide to form product. Okay, so acetic acid is an analyte. Okay, vinegar is the sample. Sodium hydroxide is the titrant, where known concentration of solution. Okay, for example number 1. So this is the titration between strong base and strong acid. Okay, so 35 ml of 0.10 molar sodium hydroxide neutralize 25 ml of hydrochloric acid. Determine the concentration of the acid. Okay, so this is example of direct titration between sodium hydroxide, okay, which is strong base, react with hydrochloric acid, okay, which is strong acid. Okay, so 35 ml of 0.1 molar sodium hydroxide need to neutralize 25 ml hydrochloric acid. So in this titration, sodium hydroxide being as titrant, right? So 35 ml need to neutralize. It means that 35 ml of sodium hydroxide of titrant, okay, need to react with 25 ml of HCl until the reaction complete or to reach equivalence point. So 35 ml is the titrant. Okay, so the question is determine the concentration of acid, right? So first we have to write the balanced chemical equation. This is one step of reaction. So from balanced chemical equation, there are 1 mole of hydrochloric acid react with 1 mole of sodium hydroxide. Okay, from the question asks to find the concentration of hydrochloric acid, okay, or the molarity of hydrochloric acid. Okay, so the formula of molarity of hydrochloric acid is the number of mole of solute of hydrochloric acid over volume of solution in liter. Okay, so the unit of molarity is mole per liter. Okay, this is that we want to find, right? So after we write the balanced chemical equation, we know the ratio between number of mole HCl and sodium hydroxide. Okay, based on the titration, given the molarity and the titer of base, okay, so we can find the number of mole of sodium hydroxide react, okay, from the molarity and volume of titer. So we can find number of mole from the unit mole per liter times with volume of titra. So you can find mole. Okay, so 0.1 molar times 35 ml change into unit liter. Okay, times exponent negative 3. So the number of mole of sodium hydroxide is 3.5 times exponent negative 3 mole. Okay, so by equation, comparing the equation to find number of mole HCl reacted. Okay, so 3.5 exponent negative 3 mole sodium hydroxide times 1 mole hydrochloric acid over 1 mole of sodium hydroxide. So we can identify the number of mole of hydrochloric acid HCl, which is 3.5 exponent negative 3 mole. Okay, equal because there are 1 mole between HCl and sodium hydroxide. Okay, so to find molarity, since we have find number of mole of HCl, and then we have to divide with volume of solution. Okay, in flask, the volume of solution of HCl is 25 ml. Okay, so to find molarity, don't forget the unit. Okay, mole per liter. So since we have find number of mole HCl, divide with volume solution, change into liter. So 25 ml change into liter times exponent negative 3, and then you can find molarity 0.14 molar. Alright, or you can use this formula, MAVA over MBVB equal A over B. So M is molarity, A for acid, B for base. Okay, V volume. Now A here is coefficient or stoichiometry of HCl acid. B is coefficient of base. Okay, from equation. Okay, you have to write the equation first. Okay, so you put into the formula and you can find the answer 0.14 molar. But for this, when you use this formula, because the question asks you to find the molarity, so you can use this formula. Okay, between strong acid and strong base. Okay, together with the coefficient. Okay, for example 2, a 0.2638 gram soda ash is analyzed by titrating the sodium carbonate with the standard solution 0.1288 molar hydrochloric acid solution require 38.27 ml. Okay, so the reaction is, after the equation have balance, 1 mole of sodium carbonate react with 2 mole hydrochloric acid to form product 1 mole carbon dioxide plus 1 mole water H2O plus 2 mole of sodium chloride. Calculate the percentage of sodium carbonate weight per weight in the sample. Okay, first of all, you have to understand the situation of titration. Okay, so actually, alright, so actually the soda ash is a sample. Okay, soda ash is a sample, so mass is 0.2638 gram. Okay, in sample soda ash that contain sodium carbonate. Sodium carbonate is analyte. Okay, so titrate with standard solution HCl. So when standard solution, known concentration or molarity 0.21288 molar. Okay, where require 38.27 ml to reach the equivalence point or to make the reaction complete. Okay, so 38.27 is a titer that make the reaction complete. That's why come up with this equation. Okay, so calculate the percentage of sodium carbonate weight per weight in sample. So actually is the formula of percentage weight per weight of sodium carbonate. Okay, so sekarang nak cari percentage analyte in sample. So mass of analyte or mass of sodium carbonate over mass sample. Okay, both in gram unit times 100%. Okay, actually the percentage weight over weight, the formula you learned previously in chapter 1. Okay, percentage weight per weight, weight per volume, volume per volume. Alright, so now the question is to find percentage weight per weight of analyte. Okay, so you have to find mass of sodium carbonate. Here, mass of sodium carbonate. From the reaction, you have to find mass sodium carbonate. Before you want to find mass sodium carbonate, you have to find mole sodium carbonate. Okay, you can find mole of sodium carbonate by comparing the equation. Okay, equation where sodium carbonate plus 2 mole of hydrochloric acid. Alright, so from equation from that you have to know first mole of HCl. Okay, so this is the relationship how of flow, how you want to find the answer. Okay, first you have to reverse back. Okay, to find mass of sodium carbonate, you have to find mole of sodium carbonate from equation. Okay, before that you have to find mole hydrochloric acid. So first step, you have to find mole HCl first. By comparing equation, you can find number of mole of sodium carbonate. Then you find mass sodium carbonate. And then put into the formula. Mass sodium carbonate over mass sample soda ash given time 100%. Okay. So first you have to find mole HCl first from the direct titration. So given for HCl, given molarity, right? Molarity 0.1288. Molarity and volume. Here, you change to liter. From ml, change to liter. Okay, so you can find number of mole of HCl for number 1. Okay, so we look at the solution here. Like I mentioned just now. Okay, first you have to find the number mole of HCl. Okay, so given molarity HCl is titrant, given molarity and volume titer. So you can find mole of HCl here. Okay. From the unit molarity, mole per liter times volume in liter. So volume we have to change to liter. Okay. Given in statement is in ml. So change to liter times exponent -3. So from mole per liter times liter, you can find unit mole. So number 1, mole HCl. Follow the flow. Okay. Or you have to find the concept, and then you easier for you to understand. Next, after find mole HCl, find mole of sodium carbonate. Okay, number 2, to find mole sodium carbonate, comparing the equation. Okay. So from mole of HCl, 4.929 exponent -3 mole HCl time 1 mole sodium carbonate over 2 mole HCl. This is from equation. Okay, this one. Or from this one. Okay, 1 mole sodium carbonate react with 2 mole hydrochloric acid. So, comparing the equation to find number of mole of sodium carbonate. Okay. So, here 1 mole sodium carbonate over 2 mole HCl times mole HCl. So, you can cancel unit of HCl to find mole of sodium carbonate. So, you will get 2.465 exponent -3 mole sodium carbonate. Okay. This is the important part from equation. Okay, you have to find 1 mole of substance. 1 mole of sodium carbonate divided by 2 mole of HCl times mole of HCl. Then you can know the relationship how to find the answer. If you just divide 1.2, okay. Tapi you tak tulis mole apa, mole sodium carbonate divide by mole apa. So you cannot know the relationship how to find the answer, okay. So you must write the substance, mole of what, okay. So for example, number 2, to find mole sodium carbonate, you cancel unit HCl to find mole sodium carbonate, right? Number 3, the flow. Okay, from equation you have already find mole sodium carbonate. Next, find mass of sodium carbonate. How to find mass of sodium carbonate? So from mole sodium carbonate to get gram. Okay. So what unit you have to times here? Okay, this is molecular weight, gram per mole. So you can cancel unit mole to find gram. Okay. For number 3 calculation, 2.465 exponent -3 mole sodium carbonate times with molecular weight sodium carbonate, then you find gram. So before that you have to find the sodium carbonate molecular weight. Okay, so 2 times atomic weight for sodium 23. Okay, plus carbon 12 plus oxygen times 3, 16. Okay, so you can find here 105.99 gram per mole for atomic molecular weight sodium carbonate. So you can find mass. Okay, number 4. The question asks you to find percentage sodium carbonate weight per weight. Okay, So include the mass of sodium carbonate here, 0.2612 gram over 0.263 gram. This one mass sample given in statement. Okay, soda ash, the sample. Okay, here mass of sample. So mass of sodium carbonate analyte divided by mass sample time 100%. So the answer is 99.02% weight per weight. Okay, means that the analyte react more, okay, in the reaction. Okay, so if in the question example, for example 2, if the question does not give you the balanced chemical equation, so you have to write the balance equation first. Okay, if not given, you have to do by your own. Alright. Okay, let's try to calculate this question. Okay, so the situation of question is sample of diprotic acid, okay, 0.8365 gram was dissolved in 75 ml distilled water. Okay, so the solution now is in conical flask. Okay, and then indicator was added. And titrate with sodium hydroxide solution. So 35.35 ml needed to reach endpoint. Okay, so means that when 35.35 ml solution sodium hydroxide delivered to conical flask. Okay, so the indicator change color. So this volume is called as titrate, okay, to make the reaction complete. So the question is calculate the molarity of base. Okay, so if you use method 1, okay, so if you use method comparison from chemical balance equation, okay, if from the equation 1 mole of diprotic acid react with 2 mole of sodium hydroxide to form product. Okay, so to find molarity of base, okay, we want to find the unit of mole per liter of sodium hydroxide. Okay, so from the statement of question, okay, you can find the mole of diprotic acid, okay, from given mass, and then you can find mole of diprotic acid. Okay, and then you can find mole of sodium hydroxide by comparing the equation here. 1 mole of diprotic acid equal 2 mole of sodium hydroxide. Then you can find the molarity of base. Okay, so we go to the solution for method 1. Okay, so first find the mole of diprotic acid, okay, from statement. Okay, given mass. Okay, molar mass also given in the statement of equation. So you can find mole of diprotic acid here. Okay. So to find mole of sodium hydroxide reacted, we can compare from equation. Okay, so 5.577 exponent negative 3 mole diprotic acid times with information from equation. Okay, so times with 2 mole sodium hydroxide divided by 1 mole diprotic acid. So you can cancel unit of diprotic acid here to get the desired unit, which is mole of sodium hydroxide. Okay, so the answer is 0.1115 mole of sodium hydroxide. Okay, next you can find molarity of base. Okay, from mole base calculated before, divide by volume of sodium hydroxide, volume of titral given. Okay, during titration, so 35.35 ml needed to reach endpoint. So to find molarity of base, mole of base divided by volume of base, volume of titral, change to liter. Okay, don't forget to change from ml to liter, and then the answer is 0.316 molar. Or you can use the formula. Okay, the formula of from molarity acid times volume acid divided by molarity base, volume base, equal to A coefficient of acid, B coefficient of base. Okay, to find molarity of base, okay, the question asks you to find molarity of base. So we have to know the value, molarity acid, volume base, and coefficient. Okay, so to find molarity acid, you have to calculate first volume given for acid, volume base given. This one from equation. Okay, so first find the molarity of diprotic acid. Okay, given mass of diprotic acid, you can find number of mole of diprotic acid. Okay, given molecular weight of diprotic acid, we can find number of mole of diprotic acid, and then divide the volume of diprotic acid, the solution 75 ml change to liter. Okay, so the solution in conical flask is diprotic acid. You will find 0.0744 molar. Okay, and then put into the formula molarity of acid, volume acid divided by molarity base, you want to find, and then the volume of base, volume of titral, equal A. A is the coefficient. A is coefficient of acid, so 1 mole of diprotic acid from equation, and then divide by B. B is coefficient of base from equation. There are 2 mole of base. So you will get the 0.316 molar. Same answer with previous method. Okay, next example. Calculate the concentration of vinegar in percentage weight per volume for a titration of 25 ml vinegar, which was primarily diluted 10 times, 25 ml into 250 ml, reacted with 22.4 ml of 0.1 molar sodium hydroxide standard solution. Okay, so given balance equation, 1 mole of acetic acid react with 1 mole sodium hydroxide to form product. The question is find concentration of the question is find the concentration of acetic acid in vinegar in percentage weight per volume. Okay, so the equation asks you in percentage weight per volume means that mass of acetic acid over volume sample. Okay, the unit mass in gram over volume sample vinegar, unit in ml times 100%. Okay, so same method with previous example. To find the percentage weight per volume, you have to know mass of acetic acid. Okay, next you have to find mole acetic acid and from equation. Okay, before that you have to know mole of sodium hydroxide, okay, that react with the acetic acid. So we go to the solution. Okay, given base as a titrant, okay, given molarity of titrant and the volume of titral, okay, 22.4 ml, need to reach endpoint. Okay, so to find mole of sodium hydroxide reacted, 0.1 molar times volume sodium hydroxide titral. So from mole per liter times with liter, you have calculate the answer is 2.24 exponent negative 3 mole base. Okay, so to find mole of acetic acid, we compare from equation. Since 1 mole of acetic acid equal to 1 mole of sodium hydroxide, so to find mole of acetic acid times with mole sodium hydroxide, so we can cancel mole sodium hydroxide to get mole acetic acid. Okay, so since same ratio, get the same answer, 2.24 exponent negative 3 mole acetic acid. Okay, but remember from the statement of question, okay, the acetic acid was diluted. Okay, so this is the number of mole of acetic acid after dilution. To find number of mole acetic acid before dilution, okay, since the dilution factor is 10 times, okay, from 25 ml dilute to 250 ml, okay, so 10 times factor. To find number of mole acetic acid before dilution, number of mole acetic acid after dilution times 10, the factor, so 0.0224 mole acetic acid before dilute. Okay, so to find mass, after that find mass acetic acid, so 0.0224 mole acetic acid times molecular mass of acetic acid. So you can find this one, carbon 12 times hydrogen times 1 times 3 plus carbon 12 plus 16 plus 16 plus 1 equal to 60 gram per mole. So you can find mass by times mole with molar mass, and then 1.344 gram acetic acid, okay, divide with volume of sample vinegar 25 ml times 100%, and then you will get 5.38%. Okay, for direct titration, if the reaction does not give you balanced chemical equation, okay, you have to write the balanced chemical equation. And that's the first one, conclusion for direct titration. Second one, the question that can be asked in terms of concentration. Okay, the objective of volumetric analysis to determine the amount of substance in sample or to determine the amount of analyte in sample. So the question can be asked in terms of concentration, okay, not only molarity. Another question that can be asked is percentage weight per weight or weight per volume. Okay, this one is also another types of concentration.